Hello class, and welcome to section 7.3, which is about multiplying special cases of polynomials. This will be the last section of the part 1 test for chapter 7. By the end of today's lesson, you will be able to identify special cases of binomial multiplication and use those shortcuts. So the first one is when we have the sum of squares. Sometimes you'll see it written as a square. So for example, you might see it written out as x plus 7 squared. You might also see it written out longhand, saying x plus 7 times x plus 7. Something like that where both binomials match exactly. When this happens, the shortcut is to square the first term, multiply the two terms and multiply them by 2, and then square the last term. Why does this work? So, if I've got a plus b times a plus b, following FOIL, the first thing I'm going to do is first terms, so a times a, which is a squared. The second thing I'm going to do is outside, which is a times b, or ab. The inside terms are also going to be b times a, which we can rewrite in alphabetical order as ab, and then our last terms are going to be b and b, giving us b squared. The ab and the ab goes to 2ab. So when you're doing this, your shortcut can be squaring the front, taking the second part would be multiplying a times b, and then multiplying that by 2, and then your last part would be squaring the back. So what does that look like when we have actual numbers? So we've got 8c plus 4d squared. So I'm going to start, and I would say that that first term, 8c, needs to be squared. For the middle part, I would say I need to have 8c times 4d times 2, and then for that last part, I would say that I need 4d squared. So now simplifying that, that's going to give me 8c squared gives me 64c squared. 8c times 4d gives me 32cd, but then we're multiplying that by 2. So I get 64cd, and then the last part is 4d squared, which means we're adding 16d squared. So instead of foiling it all out, you can do those 3 shortcuts. You don't have to write that part down. If you can do it mentally, that's up to you. Go ahead and try this one on your own. Square the front, multiply the middle, and then multiply by 2. Square the back gives us x to the second plus 6x plus 9. This pattern also holds true if it's the difference of squares. So if I've got x minus 7 to the second power, or x minus 7 and x minus 7. Again, when those binomials match exactly. Same concept applies. We end up squaring the front. Now it's subtracting the middle and then adding the second square. Why does this happen? So we've got a minus b times a minus b. Again, following the rules of FOIL, we square the first part. Then when we have the second part, we've got an a times a negative b, giving me negative ab. And then when we have the inside, again, we have negative ab. And then for our last part, we end up with negative b times negative b. Negative and a negative give us a positive, combining those two to get to our negative 2ab in the middle. So for example, if I've got 6p minus 1 squared, I'm going to take that first term, and I've got 6p, and I'm going to square that. For the middle part, we take our numbers, 6p times negative 1, and that's being multiplied by 2. And then for that last part, we have negative 1 being squared. So we've got, as we finish out our answer, 36 6p squared. 6 times negative 1 gives me negative 6p times 2 is subtracting 12p. Negative 1 squared gives me a positive 1. So we end up with 36p squared minus 12p plus 1. Again, if you don't need to write out these steps, you can do this mentally. Go ahead and try this one on your own. Square the front, multiply the middle, square the back gives us x squared minus 8x plus 16. The last special case we have is the product of a sum and a difference. So this is saying a plus b and a minus b. So we're going to go ahead and say, for example, if it was x plus 7, x minus 7. So the first two terms have to be the same. Second two terms have to be the same. But notice now one is positive and one is negative. This is going to get us a squared minus b squared. Why does this work out? Again, if we start with our foiling, ab and a plus b, a minus b, our first term is a times a, or a squared. Our outside terms are a times negative b, or negative ab. Our inside terms are b times a, or positive ab. And our last is b times negative b, which gives me the negative b to the second power. So, this middle portion of subtracting ab and adding ab cancel out, which is why we just have the front squared minus the back squared. This is a subtracting b because we have a positive and a negative. So, for example, if I have 3n plus 2 and 3n minus 2, I can show my work by saying 3n being squared, and then the back part is 2 times negative 2, giving me a final answer of 9n squared minus 4. Go ahead and try this one on your own. We end up with 16c squared minus 49d squared. So we can use this to help us do some mental math and find squares of large numbers. So if I'm looking at 94 squared, I can break this down into a sum of squares. Just so you are aware, there will be a portion on the test where you will not be able to use a calculator and you will have to use these mental math methods in order to solve these problems. So 94, I can say, is 90 plus 4 squared. So I'm able to break it down into two pieces. Then I can use my sum of squares shortcut. So I can say 90 squared for the first part, and then we can say 90 times 4, and that's being multiplied by 2 for the second part, and then that last part being 4 squared. So I can take my different pieces and I could say, okay, 9 squared is 81, and then since we're squaring it, we're going to add the 2 zeros to make it for the 90, and then we're going to add on 9 times 4 is 36, add a 0 gives me 360, multiply by 2 gives me 720, and then 4 squared is 16. Then all you have to do is add up those numbers, and that's going to give you your final answer of 8,836. So you were able to square that number without being able to use a calculator. Go ahead and try this one on your own. Again, you can break this down. 30 plus 7 is going to give you 37. Square the 30, multiply and then multiply by 2, square the 7, gives you a final answer of 1,369. So that's a quick way we can use mental math to help us solve for the square of large numbers. The other mental math trick that we're going to be able to use involves our sum and difference of squares. So if you notice, we've got 198 times 102. These numbers may seem random at first, but you can look quickly and see that this number is 200 minus 2. Well, 202 is 200 plus 2. So that quickly allows us to use our shortcut for when we have one subtracting and one adding. So we can follow our rule here and say we're going to do 200 squared, and then the second part is negative 2 times 2. When I do 200 squared, I'm going to end up with 2 squared, which is 4, and then squaring those zeros means that I have twice as many, so I end up with 40,000 minus 4, giving me a final answer of 39,996. So when I multiply those two numbers, I can do that by using my sum and difference of squares. Go ahead and try this one on your own. This time you're adding or subtracting 1 from 120. So we're going to do 120 squared. The 12 squared gives us 144. Doubling the zeros gives us the 2 zeros. Negative 1 times 1 is negative 1. So we end up with 14,399. If you have questions about this or anything else from the lesson, please let me know when you get to class.